Derivative and integration of bases other than e. Okay, you guys ready? Pull out your notes, guys. We're continuing your notes. Last time we had the derivative of e to the u. And remember, that was a sing-song. The derivative of e to the u is e to the u du dx. Do you remember that? E to the u du dx. A to the u is similar, but it's got an extra thing. A to the u is a to the u times ln of a times du dx. It's the same thing as e to the u du dx, but it's got this extra ln of a. And what is a? A is just some number. Is everybody good with that? U always has an x in it, so u has some sort of x in it, but a is just some number. Okay, so don't get this confused. The derivative of x cubed, the derivative of x cubed is not an a to the u problem. Are you guys good with that? The derivative of x cubed is a power rule problem. That's 3x squared. But the derivative of 3x, now do you see it's an AU problem? Okay, the derivative of 3x is a to the u ln of a times du dx. So that's, you copy it, a to the u, you multiply it by the ln of 3, and then you multiply it by the derivative of your u. Your u now has gone up here. This is your u. So the derivative of x is 1. Okay, so everybody see that? You'd multiply all these together. Your 3 can't multiply by your 1 because it's part of the ln family. So all of it would just stand together. You could actually make the 1 disappear because it's multiplication. Okay. Now, do you see your e to the u is actually the same formula? It is e to the u times du dx. And there's also an ln of a, but this a is just e. But guys, what is ln of e? 1, because the apple here is 1. When you log a tree, the apple falls from the tree, it's 1. So these are basically the same formulas. It's just like when we talk about e to the u, we just don't talk about this factor because it's just 1. But if you want to talk about it, you can. If you want to memorize both formulas the same way, you can. Okay? All right. So that means, though, when you walk backwards, that the integral of a to the u, okay, is actually a to the u over ln of a. ln of a plus c. So can you guys please pull out your formula sheets? Okay, please pull out your formula sheets. And if you're doing u substitution, okay, this is going to be a formula. Okay, if you're doing pattern recognition, okay, your formula is going to be a to the u dx. This will be a dx if you're doing pattern recognition, and that formula will be a to the u ln of a plus c. But you're going to have to, with pattern recognition, you have to manually go in and divide by your u prime. And I can't tell you how many times you guys think you know how to do pattern recognition, how you think you know how to do the shortcut, okay? But you don't go in and divide by this u prime, and that's wrong. And then I also can't tell you how many times that students who are doing u substitution, okay, would do u substitution and then come in and divide by u prime. Guys, you do one way or the other. You don't do both. Is everybody good with that? You decide to do the shortcut, you do the shortcut. You decide to do u substitution, you do u substitution. But you don't combine these two methods and do both. Okay, so I'll talk about both methods today. But you choose which method you're going to do. And whatever method you do, make sure you do it right. I just think I could always just do u substitution, but I'm trying to be merciful and show you the shortcut. Okay, but if you do the shortcut wrong, you should have just done u substitution in the first place. Okay, just letting you know, because the shortcut is really easy to do wrong. Okay, so guys, go into your formula sheets, please. You have that new formula. The integral of a to the u is a to the u over ln of a. All right. Okay, so let's look at how to do this. First, let's do the derivative. Okay, so the derivative of 5 to the 2x. Okay, now the x is not in the base, the x is in the exponent. So that's why I know it's an a to the u problem. Okay, the derivative of a to the u is a to the u times ln of a times du dx. There's 3 parts to it. So I need 3 parts here. Okay, first, it's ln of a. So do you see you copy it? Then you multiply, I'm sorry, did I say ln of a? Yep. Sorry. First, it's just 5 raised to the 2x. You copy the a to the u. Then you multiply by ln of a. Now this is my a right here. So this would be ln of 5, okay? Then you multiply by the derivative of your exponent. What's the derivative of 2x? 2. So guys, you might think that you can multiply the 5 and the 2, but you can't. because do you see the 5 is part of the ln family? So really you're stuck. Like you can't multiply anything. You might think you can multiply this 2 and this 5, but this 5 belongs to the 2x family. Do you see that? Everybody's in a family, so you just kind of keep it the way it is. Okay, if this is right, then what that means is the integral of this. So let me just write it. The integral of 5 2x times ln of 5 times 2, and then I'll put in the dx, okay, dx, must be equal to 5 2x. Is everybody good with that? That must be equal to 5 2x plus c. Do you agree with that? Okay, so if this is a derivative, then the integral of this must be equal to 5 2x plus c. All right, so I'm going to do it with u substitution first. Let's do the integral of this separate. Okay. Okay, we know what the answer is supposed to be. Is everybody good with that? So let's work it to the answer. So let's say I get this on my test. I look at it. I'm like, oh, man, what am I going to do? Okay, no, don't quit. Look at that and say, what is your u going to be? Do you see this could possibly be my u, right? So make that your u. U equals 2x, okay? Guys, u substitution works the same way all the time. Those of you guys who are getting your pattern recognition, your shortcut wrong, just do u substitution, okay? It takes more time, but you'll get it right every time, okay? What is the derivative of 2x? 2. Now remember, get notation right. Du dx is what derivative means, okay? Some of you guys are doing this. Du equals 2. That's incorrect. There's nothing, du doesn't mean anything in calculus, okay? It means something in English, okay, do, but we don't, that doesn't mean anything in calculus. It means something for Nike, do it, okay, but it doesn't mean anything in calculus, okay? You need du dx, all right. Then what you need is force this into a fraction, cross multiply. So I get 2 dx equals du. Solve for dx, so I get dx equals du using real algebra, okay? Then I substitute 2 things. What 2 things do I substitute? I substitute my u and I substitute my dx. So there's my dx right there. Everybody good with that? If you don't circle it, you don't substitute it, okay? So what I get is 5u times ln of 5 times 2 times du over 2. And this right here, guys, if you're doing u sub on your test, this is the key that I'm looking for, okay? If you're doing pattern recognition, I'm looking for, did you actually divide by u prime? Okay, so this is your u sub. Then do my x's cancel out? Look at that. Do I have any x's? No, so good, my x's cancel out. Do you see anything else that cancels out? The 2's. That's just like a nice thing, right? The 2's cancel out, okay? Now I want to ask you something. I'm going to pull out my scalars. This is the tough part, but if you do these problems, you'll get it right. What is my scalar in this problem? Do you see it? There actually is one. It's not 5, because the 5 is attached to the u. ln of 5. Why is ln of 5 a scalar? Because you can punch in your calculator. Go in your calculator, put ln of 5. It's like pi. Does that make sense? It's a number, okay? It's not, there's no x's involved with it, okay? So it is a scalar, even though, okay, I want to tell you, even though it doesn't look like a scalar, it's a number. So pull out the ln of 5. Then what I have is 5 to the u du. Is this something on my formula sheet? It's not an easy antiderivative because the u is in the air, okay? So it's not an easy antiderivative. But do I have an a to the u on my formula sheet? What is the integral of a to the u? A to the u over ln of a, right? So what I do is I say this is equal to ln of 5 times a to the u, which is 5 to the u over ln of 5. Do you see that? That is the integral of 5 to the u, okay? Then add Charlie, okay? And that is basically my answer, but do you see that ln of 5's cancel out? Okay, so that's basically my answer, but ln of 5's cancel out. So the answer is 5u plus c, and that is a great answer. It's just the wrong answer because you need to come in and put in your 2x, okay? Now let me tell you something about u substitution. Most people who are doing u substitution actually do it right. It's because u substitution, you just follow the same method all the time. So most people who do it actually get it like 100% every time. But there is one mistake that students do. And what they do is they get confused between the u substitution and the shortcut. They'll get this answer here, and then they'll be like, oh, I have to divide by u prime. No, you don't. No, you don't. Not in u substitutions. Everybody good with that? The dividing by u prime is only if you're using the shortcut, and I did not do the shortcut method here. Like, you look at my board, like I took up the whole board. There's no way that was a shortcut. Is everybody good with that? Okay, so don't go back in and divide by u prime. That's the shortcut method. Okay, now let's do the shortcut. How would we do the shortcut? The shortcut is this. What you do is you box in what you think is your method that you're going to use. And I'm like, this is my u, so I think it's an a to the u problem. So I'm going to box it like this. I'm going to box it. Okay, then I'm going to say, what is the antiderivative of a to the u? The antiderivative of a to the u is a to the u divided by ln of a, right? ln of 5. Is everybody good with that? Okay, okay, plus c. All right, so the derivative of this is a to the u divided by ln of a. But I'm doing the shortcut method. So I have to manually go in and divide by what? U prime. Everybody good with that? So only when you're doing a shortcut do you manually go in and divide by u prime. If you're doing u substitution, do not go in and divide by u prime. Okay, so then I need to divide everything else. But I box this in, which means don't touch this. Okay, divide everything else by u prime. There's my u. Okay, circle it to make sure that I don't change my u. If that's my u, what's the derivative of 2x? 2. Do my x's cancel out? Yes, there are no x's. If there are x's, they better all cancel out. If they don't, this is not a method. You're not allowed to use a shortcut method. Everybody good with that? Your x's must cancel out. The good thing is there are no x's. Another good thing are your 2's cancel out. And so do you see this answer is ln of 5 times this over ln of 5, because that's what you have left. Okay, everything you have left, you put here, multiply it all together, and basically you end up with the same thing, 5 to the 2x plus c. Okay, so again, just a warning, the shortcut method, while it's very, what's the word I'm looking for? Like you want it. What's that word I'm looking for? Desirable, very good. Well, it's very desirable. There's a big chance that you'll make mistakes. Okay, so let's do this again. Let's take the derivative of 3 raised to the x squared minus 2x. Okay, now this is an a to the u problem. The derivative of a to the u is a to the u times ln of a times du dx. There are 3 parts. So the derivative of 3 raised to the x squared minus 2x is going to be a to the u, so this is my u, so it's 3x squared minus 2x times ln of a, that's going to be ln of, this is my a right here, the 3. So times ln of 3 times the derivative of my u. My u is right here, right? This is my u right here in the formula, so this must be my u here. The derivative of your exponent is 2x minus 2. Okay, there are 3 parts, and just be okay with it. You got to just settle for, you can't multiply anything together. Is everybody good with that? It's just pretty much stuck. Okay, now if I take the integral of this, see, do you see this is the same thing? I should get 3x squared minus 2x back. You guys good with that? So let's see how to do that. Okay, first guys, I'm going to start with u substitution. I'm going to look at this problem, and I have 2 possibilities for my u. This is in parentheses, and this is in parentheses. Do you see I have 2 possibilities for my u? Okay, when I have 2 possibilities for my u, which one do I choose? Do you remember? The one with the higher power. Everybody good with that? So between these 2, which one has the higher power? X squared minus 2x. So u equals x squared minus 2x. Okay, I'm doing this problem. Well, I'm trying to, maybe I should move this. I can't. Okay. So u is equal to x squared minus 2x. What's the derivative of that? 2x minus 2. What's dx going to be equal to? Cross multiply. You guys good so far? I'm going to substitute 2 things, okay? The 2 things I'm going to substitute, I'm going to circle, okay? So the first thing is dx. The second thing is my u. My u is right there, okay? If I didn't circle it, I'm not going to replace it. So what I get is a quantity 2x minus 2 times 3u times ln of 3 times, now this dx is over here, du over 2x minus 2. And I ask myself the question, do my x's cancel out using real algebra, not the fake stuff? Do they cancel out? Yes. Okay, so the 2x minus 2 is going to cancel out with the 2x minus 2. Now make sure you understand, if I had this, the x's would not cancel out. Is everybody good with that? Because that would be using fake algebra. Okay, these x's don't cancel out because of this minus sign. Okay, but I do have 2x minus 2 over 2x minus 2, so they cancel out. So let me write down what I have left. Okay, this is really very cloudy. You really want to pull out your scalar. What's my scalar in this problem? What's my scalar? Guys, the 3 is attached to the u. Yeah, it has to be ln of 3. Do you guys see that? Okay, so pull out the scalar. The nice thing about the scalar is all you do is you reattach it later, okay? Now, this should be an easy antiderivative, which it's not, because an easy antiderivative, the u should be on the bottom, not in the exponent. So it should be something on my formula sheet. Do I have an integral of a to the u on my formula sheet? Yes. The integral of a to the u du is equal to a to the u over ln of a. Okay, so I'm using u substitution. So I'm going to just substitute that here. This is ln of 3 times a to the u, which would be 3u over ln of 3 plus c, and bam, that is my answer. Okay, it is the wrong answer. First of all, I could simplify. You guys good with that? So the ln of 3's would actually cancel out. Okay, but next, this u could be substituted with what? What is my u? X squared minus 2x plus c, and that is the right answer. Everybody good with that? Okay, I'm going to do the shortcut, but I got to tell you, the shortcut is done wrong a lot. BC took their test, and the shortcut was all over the place, all done incorrectly. Okay, so I just want to tell you, it's very dangerous to do the shortcut, but if you don't mind a little bit of danger, you can save some time. Does that make sense? But you got to do it right. Okay, so let me look at this, and I'm going to call that my u. Guys, the shortcut still has a u. That's my u. Okay, if that's my u, I box this in. And this is what students do wrong. They don't box this in, and so then their u changes. They change to anything they want. You can't change your u. Okay, I'm saying that this is an a to the u problem. So so I box in the a to the u. What is the integral of a to the u? A to the u over ln of a. So I'm going to take the integral of that. 3x squared minus 2x over ln of 3. Is everybody good with so far? But with your shortcut method, you have to manually go in and divide by what? U prime. So I'm going to come in here and divide by u prime. Now, what's my u again? 2x minus 2. Do my x's cancel out using real algebra? Yes. Okay, but what do I have left? You got to look at everything you have left. Do you see you have the ln of 3 left? So there's still an ln of 3, and you multiply everything you have left with when you took the antiderivative, and that is your answer. Okay, but do you see you can reduce here? So the ln of 3's cancel out, so you get 3x squared minus 2x plus c, and bam, that is your answer. Okay, so let's have a show of hands, but you can change your minds. This isn't set in stone. Okay, how many of you guys like u substitution better? Okay, so several of you. How many of you guys like the shortcut method better? Okay, what I'm going to do here, then I'm going to just use u substitution. If you're good with the shortcut, then you should get the same answer that I get on u substitution. Is everybody good with that? Okay, so you guys go for this problem. You do it. I'm going to do u substitution on the board. If you get the shortcut, guys, remember to check your work, because sometimes you do the homework completely wrong and you never get it right. And then you don't get it right on the test. And you're like, why did I get it wrong? Well, you never did it wrong right on the homework anyway. Okay, so let's do this. Go for it. I'm going to say this is an a to the u problem. So that's going to be my u, 3x. I'm going to take the derivative of my u. That's 3. Good notation, guys. Okay, I'm going to force this into a fraction so I can solve for dx. So I get 3 dx equals du. So therefore, dx is equal to du over 3. I substitute two things. I've already circled my u, but I'm also going to substitute my dx. If I didn't circle it, I'm not going to replace it. Okay, so I'm going to substitute two things. My u kind of looks weird, but that's my u, and my dx. Okay, then what I do is I say, do all my x's cancel out? Why, yes, they do. There are no x's, okay? Then what I do is I say, let me pull out my scalars, because this is really ugly looking. I'm going to pull out my scalar, okay? Then I'm going to say, is this an easy antiderivative? Do I have an integral of a to the u? I know I don't have a 2 to the u, but you understand on your formula sheet, I can't write every possible a. Does that make sense? I can't say, oh, if a is 2, then do this. If I do a is 3, then do this. A is just some number, okay? So do I have an a to the u? Indeed, I do. So it's 1/3 times a to the u over, what is the integral of a to the u? Oops, sorry, 2u over the ln of 2 plus Charlie, and bam, that is my answer, okay? That is the wrong answer. I need to come back in, put in my u. My u is 3x over 3 times ln of 2. And guys, you can't multiply any of these together because the ln of 2 is in its own family right here, okay? Plus c. And guys, those of you guys who did pattern recognition, did you get the same answer? Please check your work. Nice job. Okay, let's do another one. This one right here. Okay, make sure you understand this one you cannot even do pattern recognition, even if you wanted to. Let me show you why. Okay, if you say that this right here is your a to the u and this is your u, okay, you would divide by two things, right? Well, first of all, you would say this is my a to the u. So this is equal to the integral of a to the u is a to the u over ln of 4, okay? Then you divide by the derivative of your 2x, you divide by 2. Do your x's cancel out with this 1 plus 4 over 2x? You see how it doesn't cancel out? Everybody good with that? So you can't do this shortcut a to the u. You can do a different shortcut though. Do you guys see the other shortcut you could do though? Oh, I didn't even see the long division. You could do the long division, but don't do it with a to the u problems. I won't give you a long division with a to the u problems. Okay, there's another shortcut. Do you see it? What would you set your u? If your u is not equal to this, what could your u be equal to? The whole bottom. And do you know there's a shortcut for the whole bottom? Okay, but let's not do that. Let me just do the long cut and then we'll do the short. And then you guys who do the shortcut, you can check it. If this whole bottom is my u, let's do it. U equals 1 plus 4 2x. What's the derivative of this? Du dx. What's the derivative of 1? 0. What's the derivative of a to the u? A to the u times, there's three parts, remember? A to the u times ln of a, good, times the derivative of 2x, which is 2. And you can't multiply any of them together. But I can't just get rid of this 0. All right? So dx is going to be equal to du over this whole thing, not multiplied together. So 4 2x times ln of 4 times 2. I know you want to multiply the 4 and the 2. I know there's a strong urge, okay? But the 4 belongs to the ln family. So please don't take the 4 from its family. You don't even know how old it is, okay? You wouldn't want to take a 4-year-old, it could be 4, from its family, okay? All right, so what you're going to do is replace two things. We're going to replace my u, which I've circled, and my dx. So this is going to be 4 2x over u times the dx here is du over 4 2x times ln of 4 times 2. Do my x's cancel out? Those things with x in it, whatever it is, do they cancel out? Yeah, the 4 2x cancels with the 4 2x, okay? Write down what you have left. 1 over u times du over ln of 4 times 2. Okay, don't multiply the 4 and the 2. I know you want to, but the 4 belongs to the ln family. Okay, this is really messy. Pull out your scalars. Do you see it? Very good. 1 over ln of 4 times 2 is your scalar. So inside you have the integral of 1 over u du. I know they don't look like scalars, but the ln of 4, you could put it in your calculator. It's like an e or a pi. Okay, so guys, is this on my formula sheet? Yeah, what is the integral of 1 over u du? Ln of u. So your answer is ln of 4. Actually, I'm just going to move the 2 to the front, because if you move the 2 to the front, you don't have to put parentheses anymore, times ln of u plus c. And that is a great answer. Okay, it is the wrong answer, though, because what did I make my u? 1 plus 4 2x, right? So you need to come back in here. Actually, I just erased it. But this will be 1 over 2 ln of 4 times the ln of 1 plus 4 2x plus Charlie. And that is a great answer. Okay, guys, ready to do the shortcut? You guys know this is an ln of u problem, right? Okay, if I made the whole bottom my u, okay, what's the derivative? Do you remember dividing this? What's the derivative of 1? 0, right? What's the derivative of 4 raised to the 2x? 4 AU. The derivative of AU is a to the u times ln of a times, what's the derivative of 2x? 2. Okay, look at this fraction, and using real algebra, guys, not the fake stuff. Let me do the fraction. Your fraction is 4 2x over 4 2x times ln of 4 times 2. Do my x's cancel out using real algebra? Yes, they actually do, because everything's multiplied. Had there been a plus sign, it wouldn't. But guys, when things cancel out, they don't just disappear. What do they cancel out to? 1. So there's a 1 on the top, okay? So then what you have is, remember your ln problem, you take this 1 ln of 4 times 2, I'll put the 2 in the front, times the ln of the whole bottom, 1 plus 4 2x plus c, and bam, that's the shortcut for u, ln of u. And is that the same answer I got when I did u substitution? Yeah. Bam, okay, so either way, which one of you guys prefer u sub for this problem? Okay, which one of you guys prefer just the ln shortcut? Okay, so again, guys, either way is okay, but you guys got to do your shortcut right. Okay, let's go to this problem. Yes. Yes, go ahead.
Is it not possible to separate each of them into two separate?
No, because of the denominator stuck. Now, had you had a monomial on the bottom, so had you did this, then you could separate it because it has a common denominator. Does that make sense? But because it's not a heart. In celebration of Valentine's Day, do you see, it's only if it's a heart that you could separate it, and it's not a heart. Okay, yeah. Okay, let's look at this one. All right, I'm going to do u substitution. Those of you guys who are doing pattern recognition, you're on your own. Okay, here we go, u substitution. You look at this, I have 2 choices for my u. Okay, it could be this, or it could be this. Which one has the higher power? The squared one. So I'm going to make that my u. Okay, and even if you're doing pattern recognition, you should be circling that one because that's your u. Okay, all right, then I'm going to take the derivative of this. Now, those of you guys who are with me, would you like to FOIL first, then take the derivative, or would you like to do chain rule? They're both pretty much just as easy. I'm going to stick with chain rule. You guys okay with that? It's not. It looks terrible, but it's not. It's 2 times 1, which is 2. Leave the inside alone. Okay, take the power down by 1. Okay, but don't forget to multiply that by the derivative of 4 minus x. What's the derivative of 4 minus x? Negative 1. Okay, so I'm going to rewrite this. This is really du dx is equal to negative 2 times the quantity 4 minus x. I'm multiplying the negative 1 and the 2. All right, solve for your dx. Force this over 1. Okay, when I solve for my dx, I get du over just this whole thing, negative 2, 4 minus x. I can distribute it, but I actually know leaving this is going to help because you see this 4 minus x, it's up here at the 4 minus x. Okay, you could distribute it, but I can see it's going to hurt me if I distribute it. I'm going to have to undistribute it later. Okay, I'm going to substitute 2 things. I've already circled my u. Now I'm going to substitute my dx. So you're going to substitute 2 things, your u and your dx. So what you get is, if you did not circle it, you don't replace anything. So I didn't circle the 4 minus x, so I'm going to leave it alone. I didn't circle the 5, so I'm going to leave it alone. It's actually times 5 here. I did circle the exponent, so the exponent now becomes a u. I did circle the dx, so dx now becomes du over negative 2 times the quantity 4 minus x. Then I ask myself the question, using real algebra, not the fake stuff, real algebra, do my x's cancel out? Yes. The 4 minus x over 4 minus x actually cancels to 1. But guys, take a look at this. What scalar am I going to pull out? Negative 1/2. Beautiful. You guys are good at this. So this is 5u du. Okay. Then I ask myself the question, is this an easy antiderivative or is it something on my formula sheet? It is on my formula sheet. It would be an easy antiderivative if the u were on the bottom. Does that make sense? But since the u is an exponent, I do the integral of a to the u. The integral of a to the u, remember, the integral of a to the u, a to the u du, and you have this on your formula sheet, is a to the u over ln of a plus c. So this is going to be a to the u, which is 5 to the u, over ln of a, which is ln of 5 plus c, and bam, don't forget to multiply by the scalar. That is my answer. Okay, it is the wrong answer, but it's not a bad answer. I just need to multiply the -1 and the 5u, so that's -5. My u is right here, okay? So I'm going to have to put in 4 minus x squared, okay? Divide that by 2 times ln of 5, which is just 2 times ln of 5, plus Charlie, and bam, that is the right answer. Now, those of you guys who did did pattern recognition, tell me the truth. Did you get the right answer? Yes, I can do it. Okay, so let me do pattern recognition if you need help. If you did pattern recognition, you said that was your U, okay? That means you said, hey, I think it's an AU problem, so I'm gonna box that in. Everything else, the X's need to cancel out. Then what I do is I say, hey, what's the integral of A to the U? The integral of A to the U is A to the U divided by ln of A, right? That's Charlie. Multiply that by what? Now you have to force it to divide by U prime. If you're doing pattern recognition, you have to go in and divide by U prime yourself. So the derivative of this is, you still have to do chain rule, 2 times leave the inside alone, bring the power down by 1. Don't forget to multiply by the derivative of the inside. And do my x's cancel out? Yes. And what do I have left? -1/2. And do you see that should be the same answer basically that I have down here? Okay, you just with a little bit of manipulation. Okay. All right. So again, guys, like I said, pattern recognition is a lot harder, but it's actually satisfying if you don't have much time. Okay. How many problems do you have more? Oh, you're doing something else. Karina, do we have any more problems on this? Is anybody following me? Am I on this by myself? Okay, we're good. Okay, so you guys are armed and ready. I want you guys to look at homework from last night or any previous homework because we're done for our test. What questions do you guys have? Number 14, guys. We're looking at number 14 on the same worksheet. Oh, okay, yeah. This is the log. Guys, this is a great problem. Guys, there is something like this on your test. I need you guys to make sure you understand this. Guys, if you log a tree, what happens? So do you see you log a tree here? So the cat falls out, but be careful. The cat fell out, but you have not zipped your pants. Is everybody good with that? Okay. The cat fell out, but you didn't do any calculus yet. This is still an integral problem. And then just take the integral of this. Students are getting stuck right here on the integral of this. Guys, this is not a U substitution problem. I don't know if you remember, but before we learned U substitution, we learned easy antiderivatives, okay? Not everything is a U substitution problem. Then if the easy antiderivative doesn't work, that's when you go to the U sub. So a lot of you guys are making this equal to U and you're not getting anywhere. That's because this is not a U sub. It's an easy antiderivative. Do you see? You thought you got to do one problem, but check this out. Oh boy, you get to do 2 because this is really 2x, a string of terms. Does that make sense? A whole bunch of terms strung together with pluses and minuses. So this is the integral of 2x plus basically the integral of -1. That's basically what it is, okay? If you're being technical, there's a dx here and a dx here. So what's the integral of 2x? X squared. It's 2 x squared divided by 2, okay? What's the integral of 1? Very good. Bam. And that is my answer. Okay. What other questions do you guys have? Yes. Yes, because when you log a tree, the cat falls out. That's why. Let me think if I can think of another reason. Oh, another reason. Okay, you could say this. If that doesn't convince you, think of this. Remember, if you have ln of anything raised to a power, right? Can't you take this power and move it to the front of the ln, right? So that's the same thing as 2x minus 1 times ln of e. But what's ln of e? 1. Does that make sense? So 2x minus 1. Same reason. Okay, let's do another one, guys. What other? Yes. Number 11, guys. We're looking at number 11. Okay, so what we have on number 11 is the integral of 5 minus e to the x over e to the 2x dx. Okay, when I first look at this, I think I can make this whole thing my u. Okay, if this is my u, the derivative of this whole thing, the derivative of e to the 2x is e to the 2x times 2. Do you agree with that? And let's think about this. Do my x's cancel out? Let me do this. E to the 2x times 2. Using real algebra, in my numerator now, do my x's cancel out using real algebra? That's a big fat no. Is everybody good with that? Okay, because of this minus sign, okay? Maybe if I didn't have the minus sign, right, your e to the x's could cancel out. No, that wouldn't even, it still wouldn't cancel out. Okay, so here's the thing. It's not an ln. Everybody good with that? I tested it. It's not an ln problem. Okay, so that means my u is not this entire denominator. So I need to make my u something else. Or this looks like a quotient. Is there any way I can make it not a quotient? Move e to the 2x to the top. Do you guys see that? The biggest hint is anytime you see a denominator with just one thing. If you see a denominator with one thing, you can move it up. If you see a denominator with two things, okay, you got to do something else. Okay, but if you see a denominator with one thing, move that e to the 2x up. Okay, this 5 minus ex though, be careful. It was a family before e to the 2x came. Okay, so it stays a family. Okay, don't break up families in calculus, guys. We don't break them up in real life. We don't break them up in calculus either. Okay, so see, first I had a quotient rule. There was no quotient rule in integral, so I saved it from being a quotient. But guys, now I'm troubled. Now I have a product rule, and there's no product rule in integral land either. So what am I going to do? Because what I'd really like to do is just have a string of things just added and subtracted together. So guys, when you get stuck and it looks like a product rule, guess what you do? It's the big D, guys. What's the big D? Distribute. Guys, if you have a product rule and it looks like you can't do anything, then it's very likely the big D. Okay, so what is 5 times e to the negative 2x? Okay, nice. What is, okay, first of all, what's negative times positive? This is negative times positive, so that's negative. You guys good with that? Then what's e to the negative 2x times e to the x? If the bases are the same, you copy the base. What do you do with the exponents? You add them. So what's negative 2x plus x? Negative x. Is everybody good with that? Dx. And so guys, here we are. Can you guys take it from here, or are we still stuck here? Do you see you just have a string of things added together, right? So what's the integral of e to the negative 2x? The integral of e to the negative 2x is, I don't know if you guys are doing pattern recognition or not. Pattern recognition is a little bit easier with e to the u. It's harder with a to the u. Do you guys want me to do pattern recognition or u substitution here? Pattern, okay. So if I said that this is an e to the u problem, pattern recognition says, take the derivative, take the integral of e to the u. So I've memorized the integral of e to the u du is equal to, go look at my formula sheet if you don't have it memorized. The integral of e to the u du is e to the u. Okay, that is the formula. So here you're going to copy e to the u. That is the integral of e to the u. But guys, if you're doing pattern recognition, okay, I box this in. Everything else has to cancel out. So I divide by the derivative of negative 2. You got to manually push it. U prime, divide by u prime. What's the derivative of negative 2x? Negative 2. Do my x's cancel out? Yes, there are no x's. So I get negative 5/2 e to the negative x. Do the same thing with this one right here. Okay, this is an e to the u problem. I make that my u. Okay, remember I said it's an e to the u problem. So what I do is I take the antiderivative of e to the u. The antiderivative of e to the u is e to the u. So that is e to the negative x. But I did pattern recognition, so I have to forcefully manually go in and divide by u prime. Here's my u. If this is u, what's u prime? Negative 1. So you divide by negative 1. Guys, what am I dividing here? What number is really here that you can't see? 1. So what's negative 1 divided by negative 1? Positive 1 times e to the negative x plus c. So everybody good with that? And that would be pattern recognition for this problem. Okay, I think e to the u, pattern recognition is probably easier. The a to the u, you probably want to break it down into u substitution. All right, what other questions are you working on that you need help with? Number 10, okay. Okay, 10 is 2e to the x minus 2e to the negative x over e to the x plus e to the negative x over 2. Okay, so some possibilities here. You could make this your u, like this whole thing on top. Let me just give you a hint. Usually your top is not your u, okay? You could make the whole bottom your u, or you could make the parentheses your u. So there's 3 different possibilities. Let me just talk about, what if I made the whole bottom my u? Okay, I know it may not be a popular possibility. Let me make the whole bottom my u. If I make the whole bottom my u, okay, then all I have to do is divide by the top. Does that make sense? Divide the top by this derivative and see if my x's cancel out. So what's the derivative of something squared? That's chain rule, right? So isn't that 2 times leave the inside alone, bring the power down by 1, times the derivative of the inside, so it's e to the x. The derivative of e to the negative x is negative 1 e to the negative x. Okay, so that's what I have. So I have 2 e to the x minus 2 e to the negative x over 2 times e to the x plus e to the negative x times e to the x minus e to the negative x. I could take out a 2 on the top. Okay, so what would I have on the bottom? Some of you guys got to get really mad at me. Okay, on the bottom I have 2 e to the x plus e to the negative x over e to the x minus e to the negative x. Do all my x's cancel out? This cancels with this. Do all my x's cancel out? No, so it's not an ln problem. Everybody good with that? Okay, some of you guys are mad at me, I know. But you got to do it. Like, how would you know unless you did it? Does that make sense, if it was an ln problem or not? And so what I'm going to go with is I'm going to say my u is my parentheses, because that's usually what your u is, okay? So guys, 95% of the time, your u is your parentheses, okay? So make your u your parentheses. Had this been a monomial, had it just been e to the x, I would have moved it up. Does that make sense? Okay, but it's not a monomial. It's a binomial squared, okay? So what I'm going to do is do u substitution. What's the derivative of e to the x? E to the x times 1. What's the derivative of e to the negative x? Negative e to the negative x, okay? Solve for dx. Dx is du over ex minus e to the negative x. All right, I'm going to substitute 2 things. What 2 things? Ooh, I lost my dx, so this is actually important for u substitution. Usually the dx is not important, but it is if you're doing u substitution, okay? So I'm going to replace 2 things. What 2 things am I going to replace? My u, which is right there, and my dx, which is right there. That's good so far. Okay, if I didn't circle it, I'm not going to replace it. So the numerator here, I'm going to pull out a 2, guys, if you guys are okay with that, because I actually see it coming. Okay, I'll pull out a 2, so I have e to the x minus e to the negative x on the top, divided by u. Everybody good with that? This is a u. Oops, not u. It's not u. It's u squared. Is everybody good with that? Like, I leave the top. This is a u, so I have u squared. Okay, the dx has to be replaced because I circled it. So the dx is actually du over e to the x minus e to the negative x. All right. Using real algebra, not the fake stuff, do my x's cancel out? Do they? Yeah, they do. What I have is e to the x minus e to the negative x over e to the x minus e to the negative x. So do you guys see the scalar I have left in here? 2, okay? And then it clears up a lot, okay, what's inside my integral sign. Okay, here I am. Is this something on my formula sheet? No, it looks like it, but on your formula sheet, you have an integral of 1 to the u du. Okay, you do not have a 1 over u squared. It is not on my formula sheet. That means it must be an easy antiderivative. Is it an easy antiderivative? Why doesn't it feel easy? What do I need to do to make it easy? Yes, move the bottom up to the numerator, okay? Then it is an easy antiderivative. You add 1, divide by the new exponent, which is negative 1. So this is going to be 2 times what? U to the negative 1 over negative 1 plus c, okay? That's a great answer. You just want to kind of simplify things. This is really negative 2 times u to the negative 1 plus c, which is really negative 2 over u plus c. And that is a great answer. Okay, It's just the wrong answer. What is my u actually equal to? E to the x plus e to the negative x plus Charlie, and bam, that is the right answer. Okay, hopefully I did that right. Okay, any questions on that?
Miss Chang,
Yes,
could you do number 18?
18, yes. So guys, we're looking at number 18 on your homework for tonight. This is the A to the U worksheet, I assume. Let's see, 18. So guys, you can get ahead if you'd like to on your review sheet if you'd like to, and tomorrow you can ask me questions. Tomorrow, all we're gonna do is work on the review. All right, and then your test is on Wednesday. All right, this problem, you have two choices for your U. I would make this my U right here. Are you doing pattern recognition or U substitution? Are you okay if I do? Okay, I'll do U substitution if you're okay with that. Okay, so that's going to be my U. Your U, you always take the higher power. Okay, so I'm going to make that my U. The derivative of this is going to be, I know you could FOIL it, but I'm just letting you know, chain rule is actually going to be easier. I see that because that'll cancel out this 3 minus x. So 2 times 1, leave the inside alone, take this power down by 1, and then multiply by the derivative of 3 minus x, which is negative 1. So that gives me du dx is equal to negative 2 times 3 minus x. Solve for dx here. Force this over 1. Okay, solve for dx. So dx is going to be equal to du over negative 2 times the quantity 3 minus x. I know you want to distribute, but resist that urge because this 3 minus x is going to cancel out up here if I leave it. All right, so then what I do is I'm going to replace two things. I'm going to replace my u, which I've circled, and I'm also going to replace my dx, which is right here. So this is my dx right here. If I didn't circle it, I'm going to leave it alone. And some of you guys are still having trouble with, hey, what do I replace? Guys, circle your things, circle the integral, okay? If you don't circle it, you don't replace it. So this becomes the integral of 3 minus x. I didn't circle the 7, so that stays. I circled this u, so this becomes u. I circled this dx, so this becomes du over negative 2 times the quantity 3 minus x. Do my x's cancel out? Using real algebra, do they cancel out? Why, yes, they do. They cancel out to 1. Do you see my scalar in there? Negative 1/2. Pull out your scalar, because if you pull out your scalar, then what happens is it's easier to see if it's on your formula sheet or if it's an easy antiderivative. Okay, so is this an easy antiderivative or is it on my formula sheet? Is it u raised to the something or is it on my formula sheet? It's on my formula sheet. Do you see it? What's the antiderivative? And let me just carry down the negative 1/2. You don't do anything with it for a while, okay? What's the antiderivative of 7u, of a to the u? It's a to the u over ln of u. I mean, ln of a. Okay, you just memorize that. If you go look at your formula sheet, it should be there. You should have something that looks like this is equal to a to the u over ln of a. Okay, I'm just really replacing a with 7. Guys, why is a 7? Because a is just some number. I can't on your formula sheet write 7 to the u, use this formula, 100 to the u, use this formula, 5 to the u, use this formula. Does that make sense? That would be silly to do that on your formula sheet. So I just put a. A just means some number, and then plus Charlie. And that is a great answer. And actually, it is a right answer too. No, it's not the right answer. You're right. This is 1/2 times 7 raised to 3 minus x quantity squared over ln of 7 plus c, and that is the right answer. So I have the integral of e to the negative x tangent of e to the negative x dx. Okay. All right. I'm going to do u substitution on this one. This is going to be my u right here. So my u is equal to e to the negative x. All right. It's in parentheses, so that's a big Q. All right. Take the derivative of that, e to the negative x. That's negative e to the negative x, right? Oops, I was going to do plus c, but that's a derivative, sorry. And then solve for dx. I'm going to substitute two things. I'm going to substitute my u, and I'm going to substitute my dx. So what I get is an integral of e to the negative x tangent of u times du over negative e to the negative x. And I ask myself the question, do my x's cancel out? Do they? Yes, but what do I have left? Do you see the scalar I have left? -1, okay? So I'm gonna pull out that -1, and I get the integral of tangent u du. So here's the big question. Okay, I know it's not an easy antiderivative. You're good with that, right? Because it's a trig function. So this trig function should be on my formula sheet. Do I have a trig function on my formula sheet? Yes, it's -ln of, remember this tangent is sine over cosine. So it's always a denominator. So it's gonna be cosine u plus c. Oh wait, it's a negative, sorry, it's a negative, right? Yeah, because this is a negative times a negative. Okay, so that's a positive. So it's ln of cosine, my u is e to the -x plus Charlie, and that is the right answer. And a great answer. And a beautiful answer. And a nice answer. All of the above. Okay, what other questions do you guys have? 14, okay? We're looking at 14, guys, on your homework. This is the ln of e to the 2x minus 1 dx. And make sure you guys understand this. This problem is the same as this problem. Let me do this. E to the ln of 2x minus 1 dx. They're actually exactly the same. Why? Because if you log a tree, the cat falls out. And if you tree a log, the cat also falls out. Does everybody see that? I could do either one on your test. There actually is one like this on your test, okay? So here's the trick though. If you log a tree, the cat falls out. But guess what? You haven't even zipped your pants. Is everybody good with that? So the number one wrong answer here is students will write, this is equal to 2x minus 1. No, it's not. This inside here, this is equal to 2x minus 1, right? If you log a tree, the cat falls out. Another way to think about it, if you're having trouble with this, is this. If you have the ln of e 2x minus 1, if you know log properties, if this is a log, what are you allowed to do with the exponent? Move it to the front. So let me move it to the front. So this is 2x minus 1 times the ln of e. What's the ln of e? 1. Do you see that? Okay, so if you log a tree, that's why the cat falls out, because it's a log problem. But guys, you haven't even taken the integral. All you did was algebra 2. Okay, so you need to actually take the integral of this. What's the integral of 2x minus 1? Okay, you guys got it. I got to tell you, students missed this on the test, even the last test. I had students look at this and say, U substitution does not work. No, U substitution doesn't work. The reason is because, I don't know if you remember, we didn't learn U substitution until we did easy antiderivatives first. Do you remember that? You do easy antiderivatives first. If that doesn't work, then you try U substitution. Not every problem works with U substitution. It could just be an easy antiderivative. So this actually is an easy antiderivative. They are two separate problems just strung together with pluses and minuses. So you thought you had to do one problem, but look, oh boy, you get to do two. It's the integral of 2x, which is actually x squared, 2x squared over 2, minus the integral of 1, which is just x plus c. So you get x squared minus x plus c. Okay, and that should be your answer for 14. It's actually also your answer for this problem. Can you guys think about this and see why it's the same? Is everybody good with that? If you log a tree or tree a log, okay, the cat falls out. All right, what other questions do you guys have? 20? Okay. 20 on last night's homework, which is actually tonight's homework, right? Because tonight you're doing 15 to 20. So it's 2 sine x cosine x dx. All right. So what I'm going to do here is I'm going to say, I think this is an AU problem. Now, if it is, remember the x's have to cancel out. So I'm going to say, if this is an AU problem, that must be my u. So u is equal to sine x. The derivative of sine x, is it positive or negative cosine x? Derivative. Positive, right? Okay. Dx is going to be du over cosine x. I'm going to substitute two things. I'm going to substitute my u, which is already circled. I'm going to substitute my dx, which I'm going to circle. Okay, if I didn't circle it, I'm not going to replace it. Okay, those of you guys getting confused, you're not circling your integrand. Okay, circle what you're going to replace. Okay, if you don't circle it, then you don't replace it. So I just copy everything unless it's circled, and then I replace it. Then I ask myself the question, do my x's cancel out? Yeah, they do. The cosines cancel out. What do they cancel out to, though? 1, right? So I have 2u du. Is this an easy antiderivative or something on my formula sheet? It is on my formula sheet. What is the integral of a to the u? A to the u divided by ln of 2 plus c, and bam, that is a great answer. It is the wrong answer. I need to go back in and substitute my u, and I'll have the right answer. Now be careful. Let me talk to you guys about this. This is what students do wrong. They do use substitution. It's great, okay? They get here with the cosines. They cancel out. It's great. They get here, and they're like, oh, I need to divide by u prime. No, you don't. Does that make sense? You only divide by u prime if you're doing pattern recognition. Does that make sense? If you're doing the shortcut, okay? If you're not doing the shortcut, if you're doing u substitution, the u prime is already built in. Please do not go in and manually divide by something that you don't have to do, okay? All right. From your homework, what other questions do you guys have? Or any other previous homework? Number 17. Okay, number 17. And guys, I don't know if you've noticed, but what I've been doing is putting even homework questions that we talk about on our videos. So those of you guys who are like, you can't do your homework, or you're having trouble, go back to our videos, and the videos have homework problems as well as the problems that we do on our notes, okay? All right, so I'm looking at this problem, I'm saying, hey, I think this is an a to the u problem. And guys, even though this is in parentheses, like I said, there are always exceptions to the rule. This is actually my u right here, because if it's an a to the u problem, that is your u. So let me try to see if this is my u. If it's not, I'll go back. Actually, do you want me to do it the wrong way first? Are you sure? Okay, because sometimes you guys do it the wrong way, then I'll show you how you know it's wrong. How many of you guys would just like to see it the wrong way? Okay, let me do it the wrong way. Because you guys do it the wrong way on your test. That's the thing, and you don't even know it's wrong. Okay. Then if this is your u, okay, I'm going to choose the wrong u because it's in parentheses. If I take the derivative of this, you see it's a to the u times ln of a times du dx, okay? Then I solve for my dx, and sometimes, your u will look like this, okay? And I solve for my dx, okay? And remember, you can't multiply any of these things together, okay? Then you replace two things. You replace your u and your dx, okay? So this is going to be equal to x times u times, my dx is du over 5 to the negative x squared times ln of 5 times negative 2x. And do my x's cancel out? One of these x's do, okay? But the rule is everything with an x has to cancel out. And do you see this doesn't cancel out? So that's why you say, okay, back to the drawing board. This is not the right u. Let me go back and pick the right u. Is everybody good on like when to go back and pick another u? Okay, you guys need to do it wrong sometimes, okay? And that's why I do it wrong with you guys, because you need to get to the logic of, oh, I picked the wrong u. That's okay. I'm going to pick myself up and do it again, okay? Some of you guys, you get so frustrated when you don't find it the first time. I got to tell you, when I did calculus, I didn't find it the first time all the time. Okay? I just randomly picked ones, okay? All right, now I'm going to pick that as my u because I'm thinking, hey, I think this is an AU problem. That would be A and that would be your u, okay? If I set that equal to u, there's my derivative. So dx is going to be du over negative 2x. You're going to replace two things. You're going to replace your u and you're going to replace your dx, all right? If I didn't circle it, I'm not going to replace it, okay? So that's what I get. Then I ask myself the question, do my x's cancel out? Do they cancel out? Why, yes, they do. What scalar do I have left here? Do you see it? Negative 1/2. Pull out that negative 1/2, okay? Now, the answer is going to be negative 1/2 times whatever this integral is. And this should be an easy antiderivative. Reverse power rule is what I'm saying. Or it should be something on my formula sheet. It's not a reverse power rule, guys, because the u is in the exponent. So it actually is an a to the u problem. So it's a to the u divided by ln of 5 plus Charlie. Okay, and that is a great answer. It is the wrong answer. Let me multiply together first. Okay, I'm going to multiply the numerators and the denominators. Okay, but it is a wrong answer. To get the right answer, what do I need to do? Yeah, put your u back in. So that's actually negative x squared, and that will be the right answer. Okay.